This is SpaceTime, Series 23, Episode 105. Coming up on SpaceTime, a missing ingredient in dark matter theories, the first ever detection of a planet actually larger than the star it's orbiting, and the launch of a new Chinese surveillance satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered that there may be a missing ingredient in our cosmic recipe of how dark matter behaves. A report in the journal Science claims astronomers have uncovered a discrepancy between the theoretical models of how dark matter should be distributed in galaxy clusters and observations of dark matter's grip on galaxy clusters. Scientists have no idea what dark matter is. It doesn't absorb, emit, or reflect light. But they know it exists because they can see its gravitational effect on normal matter, such as stopping galaxies from flying apart as they rotate. One way astronomers can detect dark matter is by measuring how its gravity distorts space-time, an effect called gravitational lensing, and a consequence of Albert Einstein's 1915 general theory of relativity. Researchers have found that small-scale concentrations of dark matter in clusters produce gravitational lensing effects which are 10 times stronger than what they should be. The new evidence is based on unprecedentedly detailed observations of several massive galaxy clusters taken by NASA's Hubble Space Telescope and the European Southern Observatory's Very Large Telescope, the VLT. Galaxy clusters are the most massive structures in the universe. They comprise clumps containing hundreds if not thousands of individual galaxies, and so are the largest repositories of dark matter. Not only are they held together largely by dark matter's gravity, but the individual cluster galaxies are themselves replete in dark matter. So, dark matter in clusters is therefore distributed on both large and small scales. The study's lead author, Massimo Meneghetti from the National Institute for Astrophysics in Bologna, Italy, says galaxy clusters provide the ideal laboratories to test scientists' computer models of how dark matter should interact with normal matter. The problem is, the simulations are repeatedly failing to match the observations. So, clearly something's missing. Some key understanding of physics in the real universe which isn't being accounted for in current theoretical models. So this could be signalling a gap in science's current understanding of the nature of dark matter and its properties. The distribution of dark matter in clusters is mapped by measuring the bending of light or the gravitational lensing effect they produce. The gravity of dark matter magnifies and warps the light from distant background objects. So the higher the concentration of dark matter in a cluster, the more dramatic its light-bending effect. Hubble's ultra-crisp images, combined with spectra from the Very Large Telescope, have allowed the authors to produce a very accurate high-fidelity dark matter map, and in it they've identified dozens of lensed background galaxies. And by measuring the lensing distortions, astronomers could trace the amount and distribution of dark matter. The three key galaxy clusters used for the analysis, MAX J1206.2-0847, MAX J0416.1-2403 and Able S1063 were part of two Hubble surveys, known as the Frontier Field Survey and the Cluster Lensing and Supernova Survey with Hubble, or CLASH. To the team's surprise, the Hubble images revealed smaller scale arcs and distorted images nestled within the larger scale lens distortions in each cluster's core, where the most massive galaxies reside. The authors think these embedded lenses are produced by the gravity of dense concentrations of dark matter which is associated with the individual cluster galaxies. That's because dark matter distribution in the inner regions of individual galaxies is known to enhance the cluster's overall lensing effect. Follow-up spectroscopic observations added to the study by measuring the velocity of the stars orbiting inside several of the cluster galaxies. The spectroscopic studies allowed the authors to associate the galaxies with each cluster and work out their distances. And the star's speed provided an estimate of each individual galaxy's mass, including the amount of dark matter it had. The authors then compared the dark matter maps with samples of simulated galaxy clusters with similar masses located at roughly the same distances as the observed clusters. And the problem is, the clusters in the computer simulations simply did not show the same level of dark matter concentration on the smaller scales. The very scales associated with individual cluster galaxies seen in the real universe. The mystery continues. This is SpaceTime. Still to come, the first ever detection of a planet larger than the star it's orbiting, and China launches a new surveillance satellite, this one for ocean monitoring. All that and more still to come on SpaceTime. For the first time ever, astronomers have discovered a giant exoplanet orbiting around a small white dwarf star. The findings, reported in the journal Nature, may represent the first intact planet ever found orbiting close to a white dwarf, the incredibly dense burnt-out stellar corpse of a dead Sun-like star. The white dwarf, named WD 1856 plus 534, is about 40% larger than the Earth. It's orbited every 34 hours by a Jupiter-sized gas giant, accordingly named WD 1856b. The discovery was made using data from NASA's Transiting Exoplanet Survey satellite TESS and the agency's now retired Spitzer Space Telescope. One of the study's authors, Assistant Professor Andrew Vandenberg from the University of Wisconsin-Madison, says the white dwarf creation process usually destroys nearby planets, and anything that gets too close later is usually torn apart by the star's immense gravitational field. Yet somehow WD 1856b managed to survive, staying in one piece despite getting awfully close to the white dwarf. Needless to say, astronomers now have lots of questions about just how this gas giant arrived at its current location without being either destroyed or flung out into interstellar space. TESS monitors large areas of the sky called sectors for nearly a month at a time. This long, unblinking gaze allows the probe to find exoplanets, that is, worlds beyond our solar system, by capturing changes in stellar brightness caused by a planet crossing in front of or transiting its host star, as seen from TESS's point of view. TESS spotted WD 1856b about 80 light-years away in the northern constellation of Draco the Dragon. It's orbiting a cool white dwarf star, roughly 18,000 kilometres across and up to 10 billion years old. The white dwarf is part of a triple star system. When a sun-like star runs out of fuel, it swirls up to hundreds to thousands of times its original size, forming a cooler, bigger star called a red giant. Eventually, the red giant's outer layers separate from the stellar core. They float away, taking about 80% of the star's mass with them. What's then left behind is the exposed white-hot stellar core, a white dwarf, left to slowly cool over the eons of time. Now, typically any nearby objects would be engulfed and incinerated during this process, and in this system that would have included WD 1856b in its current orbit. Vandenberg and colleagues estimate that in order to survive, this planet must have originated at least 50 times further away from its current orbit. He says astronomers have long known that after a white dwarf is born, distant objects such as asteroids and comets can scatter inwards towards these stars. But they're usually pulled apart by the white dwarf's strong gravity, turning into debris disks. Now, there have been some hints that some planets can scatter inwards as well, but this appears to be the first observation of a planet making this journey intact. Now, the authors have come up with several scenarios which could have nudged WD 1856b into an elliptical path taking it around the white dwarf. And the trajectory could have become circular over time as the star's gravity stretched the object, creating enormous tides which dissipated its orbital energy. The most likely scenario involves several other Jupiter-sized bodies close to WD 1856b's original orbit. The gravitational influence of these objects could have been big enough to easily allow for the instability needed to knock the planet inwards. Other possible scenarios involve the gradual gravitational tug of the other two stars in the system, a pair of red dwarfs G229-2a and b, over billions of years, and a flyby of a rogue star perturbing the system. But Vandenberg's team thinks these and other explanations are less likely because they require finely tuned conditions in order to achieve the same effects as the potential giant companion planets would. This report from NASA TV.
NASA's TESS and Spitzer missions just discovered a strange sight, maybe the first example of a giant world orbiting extremely close to a small, dead star. The object, called WD-1856b, is roughly the same size as Jupiter, with possibly up to 14 times its mass. About every day and a half, it orbits a white dwarf, a star containing half the Sun's mass in a space only slightly larger than Earth. TESS hunts for regular dips in starlight caused when planets pass in front of, or transit, their stars. TESS discovered WD-1856b's transits, which were then confirmed by Spitzer. Finding a potential planet so close to a white dwarf is surprising. Stars like WD-1856 often start out looking much like our Sun. But as they age, they transform into red giants, engulfing any nearby planets. Then their atmospheres blow away, revealing their dead white dwarf cores. So, WD-1856b likely formed much farther away from its star. Scientists think there are several ways it may have moved inward, closer to where we find it today. Then, the effects of the star's gravity would have nudged it into its current orbit. For example, it's possible the system had additional massive planets. As the star evolved and disrupted the planet's orbits, their gravitational interactions could have kicked WD-1856b closer inward. Although the possible planet orbits the white dwarf, there are two other small, distant stars in the system. Perhaps their combined gravitational influence could have altered its orbit over time. Or perhaps a massive object from deep space, such as another star, could have thrown the entire system into disarray. No matter the cause, the system then settled into its current state over billions of years. Scientists think this finding could help us understand how other star systems, including our own, may evolve. In the meantime, though, TESS will continue its search for more potential worlds like WD-1856b, and possibly find even stranger ones.
Meanwhile, a separate study reported in the Astrophysical Journal looked at whether NASA's upcoming James Webb Space Telescope would be able to find signatures of life on Earth-like planets orbiting white dwarfs. See, a planet orbiting a small star produces strong atmospheric signals when it passes in front of or transits the host star. And white dwarfs push this to the extreme because they're hundreds of times smaller than the Sun, almost as small as the Earth in fact, thereby giving astronomers a rare opportunity to characterize rocky planets. The James Webb Space Telescope, which is slated to launch in October next year, is uniquely placed to find signatures of life such as ozone and methane on rocky exoplanets. One of the study's authors, Associate Professor Lisa Kaltenegger from the Carl Sagan Institute, says that if rocky planets exist around white dwarfs, scientists could spot signs of life on them within the next few years. The study's co-author, Ryan McDonald, also from the Carl Sagan Institute, says there are certainly rocky planets in white dwarf systems, and it's a logical step to imagine a rocky planet just like Earth orbiting a white dwarf.
In our search for life in the universe, one question we are asking is where it is. How prevalent is it? Is it everywhere? Is it nowhere? And so in this paper, what's really, really special is that we've identified a place where nobody thought to look before, and that is around a long dead star, its exposed core. And we just found the first planet around such a core that we call a white dwarf. That planet is big. It's a gas planet like Jupiter. But if that one exists, maybe smaller ones can also exist, smaller ones like our own Earth. And wouldn't it be incredibly interesting to figure out whether life could survive or start again?
This question, could there be life around a star that has died? And it has deep philosophical implications for our own future, because the sun is not going to last forever. Billions of years from now, the sun will eventually throw off its outer layers and transform into a white dwarf. But this might not be the end. If we can use our telescopes on the Earth and in space to find signs of life around dead stars, I think in many ways that gives us renewed hope for the future, knowing that life can always find a way, even if it takes billions of years. life can always survive and thrive in even the most dramatic and strange circumstances we can imagine.
Our study really identified where NASA's flagship mission, the James Webb Space Telescope, can easiest find signs of life if they exist.
And we only have to get lucky once. We only have to find one more planet beyond the Earth that has signs of life before we can start to figure out that life itself is a common phenomena in the universe. Perhaps we are not special. Perhaps we are just one of many forms of life all throughout our galaxy and even beyond.
And I would add to this, hopefully, we're not special. And we are at the verge of finding that out.
And there you heard from Lisa Kaltenegger and Ryan McDonald, both from the Carl Sagan Institute. This is Space Time. Still to come, China launches a new ocean monitoring surveillance satellite. And later in the science report, researchers identify a new gene linked to obesity. All that and more still to come on Space Time. Let's take a break from our show for a word from our sponsor, Expressvpn, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where Expressvpn can help you. Expressvpn's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
China has launched a new ocean monitoring surveillance satellite. The Haiyang 2C was flown aboard a Long March 4B rocket from the Jiaquang Satellite Launch Center in northwestern China. The spacecraft is Beijing's third ocean dynamic environment satellite, providing all-weather observations of wave and sea surface heights, as well as wind speed and ocean temperature. Importantly, the probe will also identify and monitor shipping in territorial waters claimed by China. It'll join a previous surveillance satellite, the Haiyang 2B, as well as the yet-to-be-launched Haiyang 2D satellite, providing the Communist government with uninterrupted coverage of 80% of the world's sea surface. The launch was the 347th by a Long March series rocket. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have identified a new gene linked to obesity. A report in the journal Nature claims the new gene, known as RIPK1, is linked to inflammation. Scientists found that by turning the gene off, they could dramatically cut fat levels, total body weight, and improve insulin sensitivity. The authors say the findings show that RIPK1 is genetically associated with obesity, and it could be a potential therapeutic target to address obesity and related diseases. New research suggests that silk face masks may be better and more effective at reducing the risk of coronavirus transmission than cotton or polyester versions. A report in the journal PLOS ONE says experiments showed silk masks were more resistant to water droplets and more breathable. The results suggest that silk masks could be as effective as disposable single-use surgical masks, while having the advantage of being reusable with cleaning. However, the researchers stressed that more research is needed under clinical conditions. More than 1 million people have now died and over 34 million have been infected by the COVID-19 coronavirus since it was first spread from its origins in Wuhan, China. News that US President Donald Trump and the First Lady have both tested positive for COVID-19 sparked reports on some media outlets, including Australia's Channel 10, that the diagnosis triggered the American military to launch its E-6B Doomsday planes. One Boeing E-6B Mercury was spotted flying along the East Coast near Washington, D.C., while another was observed on the West Coast in the skies above Oregon. However, a nuclear expert with the Federation of American Scientists says the flights were part of an exercise planned long ago for October. And that was later confirmed by the United States Strategic Command, a SATCOM spokesperson saying it was purely coincidental that the planes were launched shortly before the POTUS diagnosis was released. Based on the Boeing 707, the E-6B are part of the Pentagon's Operation Looking Glass airborne nuclear command posts. They're designed to take over command and control links with the Navy's fleet of higher-class nuclear submarines if ground-based command centres are destroyed in a thermonuclear attack. They allow targeting instructions to be transmitted to the nuclear warheads on Trident ballistic missiles. Archaeologists have discovered that chromium steel, similar to what we today know as tool steel, was first made in Persia nearly 1,000 years earlier than experts had previously thought. The findings, reported in the Journal of Archaeological Science, follows information revealed in a number of medieval Persian manuscripts. These led scientists to an archaeological site in southern Iran, long considered a crucible of steelmaking. There they discovered chromite in slag, suggesting the ore had been used to make chromium steel alloy. They also detected 1 to 2% chromium in steel particles preserved in crucible slags. The authors then used radiocarbon dating of a number of charcoal pieces retrieved from within the crucible slag, together with a smithing slag, to date the industry to between the 11th and 12th century, demonstrating a process that we would not see used again until the late 19th and early 20th century. A new study has found that working dog breeds aren't just hard workers, they're also the most playful. A report in the journal Biological Letters analysed 132 different breeds of dog. The playful pups were studied both with their owners and with other people. Researchers found that herding and sporting breeds were the most playful, more so than non-sport and toy breeds. This is probably because play behaviour was very important during the domestication and breeding of working dogs, thereby encouraging a strong bond between the dogs and their humans. Delays in the development of the new flagship 5G iPhone meant it wasn't part of the show for Apple's annual September product launch. Keeping a close eye on what was released and what it's got, it's a warm welcome back to Alex Zaharov-Reutt from ITWire.com.
We've got the new Apple iPads and watches, but already some of the new iPads have come onto the market. And let's start with the 8th gen and most affordable entry-level iPad. It's $329 in the US, $499 in Australia. It comes with a 6-core A12 processor, so it's a big performance increase, and it's able to do everything that iPads can do. It now uses a mouse or a trackpad if you wanted to, keyboard, you can use the pencil, you can write anywhere that you can type, and it's the platform that has all of the different apps being developed for it. You really don't see many new apps being developed for Windows. And of course, there are many more expensive iPads, but this entry-level one is a brilliant place to start, and it's the perfect sort of device for anybody that's just doing everyday computing tasks.
The thing that got me about the announcement was no iPhones. At least not yet, anyway.
Yeah, that's right. October 13th is when they're supposed to be announced. There should be 4 models, and we'll hear all about them in an upcoming show. Also launched is the new 11th generation Intel processors, and they're promising faster battery responsiveness, up to 9 hours of real-world battery life, system wake from sleep in less than 1 second, and you can also fast charge with up to 4 hours of charge with just under 30 minutes on systems with full HD displays. If you've got a 4K display, it'll chew more power. Now, obviously, this is great. New computers, very fast, but it also means that 10th generation processors in computers from last year will be on sale this Christmas and holiday season. So if you're looking for a new computer, you can go for the latest and greatest, or you can get one of last year's models at a better deal.
Are they a lot faster in terms of the amount they can process and the speed they do it in?
Every year, Intel claims that the processor is going to be faster and better. But usually what happens is that Microsoft releases an update to Windows and takes all those speed gains away. So inevitably it will be faster and better. But for the average person who just has everyday computing requirements, they might even just find that something like the iPad is more suitable. Yep.
I've just bought myself a brand new 6 terabyte hard drive, external hard drive, and lo and behold, it's out of date already. The same company, Seagate, have an 18 terabyte version available.
That's right. And by the end of the year, they will have a 20 terabyte hard drive. These hard disks are really designed for use in data centers where they need huge amounts of storage. Also, they need the drives to be sipping power, not generating too much heat. These are using HAMR technology, heat-assisted magnetic recording, and also have helium inside, which is part of what is required to enable these really large capacities. Now, the future of storage really is in solid-state drives, and perhaps in the future we'll see crystals like we saw on in various sci-fi movies. But 20 terabyte drives, it reminds me when I was a kid, we used to have drives of hundreds of megabytes. I used to dream of a 1 gigabyte hard drive. Now we have 20,000 gigabyte hard drives, and I'm looking right now at a 10 terabyte disk that I use to store my extensive photo and video collection, which people do these days, and I also have it backed up online. So the storage technologies are definitely getting better and better, and one day we'll look at 20 terabytes as being extremely quaint.
That's Alex Zaharov-Reut from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.